Hi everyone, so this is question 1. Let's take a look at the question. Okay, it mentions here that a student reading his physics book, wow, okay, on a lake dock, wow, okay, another wow, notices that the distance between the two incoming wave crests is 0.75 meter. Okay, something important. We're talking about distance here, and it's the distance between two incoming wave crests, and it's 0.75 meter. Okay, and he then measures the time interval between the crests to be 1.6 second. Time of arrival between the crest is 1.6 second. Okay, it's very wordy, so let's try to unpack this question with probably a simple diagram maybe. Well, it's a student reading physics book on a lake dock. Lake dock is like a structure that you build on the water, so you can stand on the water, or you can have the boat unload stuff at the dock, something like a jetty kind of thing. Okay, so let's say this is my dock and this is the student and he's reading a book. Okay, and he's reading a book. Really sorry for the bad drawing. He's reading a book, then he notices that because it's a lake, the lake, there will be wave at the lake. Wave. Okay, so you have wave at the lake. Then this student notices that the distances between the two incoming wave crests. So where is the wave crest? This is the wave crest. In layman terms, we call it the peak of the wave. Okay, so the distance between the two peak of the wave, which is this distance between these 2 points here, is 0.75 meter. Okay, knowing that, I think we can probably just continue to say that this is just the wavelength, which is equal to 0.75 meter. Okay, so by knowing the idea, by knowing the definition of wavelength being the distance between two successive points on the wave which are in phase, we know that 0.75 meter is the wavelength because these two crests here are two successive points on the wave which are in phase. In phase means that they are the same section of the wave. This is the peak section of the wave. This is also the peak section of the wave. So both of them belong to the same section. They are of the same phase. So this is the distance between two successive points of the same phase. That's why it's the wavelength. Okay, continue. So we also have the time interval between the two crests. Time of arrival between the crest. Okay, sorry for my misreading. Okay, time of arrival between the crest means by this student here see this crest arrive at the dock, then he starts his timer, then he wait for the next crest to hit the dock, and he stop the timer. Then you see the time of arrival between these two crests is 0.16 meter. So we can also label that the difference in time of arrival between these two crests is just 1.6 seconds. And knowing that, I think we can reasonably deduce that this is just the period. Okay, so I believe we have understand the situation quite clearly. So before we move on, let's unpack the variables or the unknowns or the quantities that you will see in this chapter, chapter 10. Chapter 10 is a continuation, or it builds on chapter 9. Okay, it builds on chapter 9 on SHM. So you still see the same thing. You still see omega, you still see period, you still see frequency. So these three things they are related together and they are all representing the representing time actually. Okay, so they are representing time, and you can convert them from one quantity to another using this formula. Omega equals to 2 pi f. Omega is angular frequency, f is just frequency. Then t is equals to 1 over f. This one, nothing changed. This is still the same thing as last time. Omega equals to 2 pi over big T. Okay, all these things are representing time, just in different way. And then you also can relate them to something called, this is an extension for chapter 10. This is not in chapter 9. I mean, these three variables here are things that you see in chapter 9. So now we add on another two stuff which you might have never seen before in chapter 9, which is the wavelength and the wave number. These two things are again connected, they are related to each other, then they are both representing distance. Okay, they are both representing distance on the wave. So how do you relate these two things? It's related by k equals to 2 pi over lambda. Okay, so we have one side representing time, one side representing distance. So how do you relate distance and time? We relate them through something called wave speed. Okay, then wave speed is equals to f lambda. Okay, there's other way of representing omega over k. That's another representation as well. So this thing is what we call as wave speed, which is the speed of the wave propagating through space. Okay, this is wave speed. So these are the few variables that you see often in this chapter. So you need to know what is representing time, what is representing distance, how do you relate time and distance. Knowing this will make things a lot easier. Okay, so let's start and solve the problem. Frequency. They ask for frequency for A. You know that frequency is just the inverse of period. So 1 over 1.6 second. Then you end up with 0.625 hertz. Okay, very direct question. The B asks for the speed of the wave. You have learned from here that it's you relate the distance and the time to obtain speed. Okay, so what can you do here? B equals to f lambda. You have your f which you obtain from A, which is 0.625. For your lambda, you can take it from here. Okay, what we extract from the question, 0.75. So 0.75, and therefore your answer will be 0.469 meter per second. That's it for question 1. Okay, the main thing that I want to highlight here will be knowing how to relate time and distance using wave speed, and knowing how to manipulate between different variables that represent time, and how to manipulate between different variables that represent distance. Okay, so that's all for question 1. Thank you very much.